So let's talk about functions. So functions relate two variables to each other. Most often we'll be talking about x and y, and a function defines how those two variables are related. So we'll have some input value and some output value, and what truly makes it a function is that every input has just one output. You're not going to be able to put something in and get multiple values out. It's always going to be one in, one out. So with that, we can think of this like a machine. So we have a diagram here of a machine where you see this x equals 4. If you plug that into the machine, inside we have this operation y equals 2x plus 3. So this y equals 2x plus 3 is defining the relationship. That's our function right there. And then what we can see is the output from the function, which says y equals 11. So what's happening here is that we have 4 is our input number, and that's defining it as x. So we have x equals 4, and then our function tells us y is equal to 2x plus 3. So if we have x equals 4, then what we would do is we would have y equals 2 times our value of x plus 3, and the value for x that we're using is 4. So if we want to find y, it's coming to 2 times 4, which is 8, and then plus 3. So that's where that output of 11 is coming in. So the property of a function is we input that 4 for x, and because of how our function's defined, we get an output of 11, which is defining our value for y. So the definition of a function, each input x uniquely determines one output y. So let's talk about this in the context of a few scenarios here, specifically with a bank account. So we want to see, is the relationship a function? So is your balance a function of your bank account number? So the idea of input and output. So is your balance, which in this case we're talking about that as the output, a function of your bank account? So we're calling the bank account number the input. So the idea is, does it make sense that if we input our bank account number, what's going to be the output? So imagine we go up to the ATM. I know typically we have a card with us, but let's say we had to type in our bank account number. Is there just a single output? And yes, because our bank account number is unique to our bank and to our account specifically. So you're not going to see a bunch of different balances and choose which one you want, as nice as that might be. Instead, it would be we type in our bank account number and we get just a single output, which would be our balance, and it would just be that one balance for that account. So this relationship of inputting a value and just getting a single output, this is a function. So I'm going to write yes, that's a function. The second scenario, is your bank account number a function of your balance? So this is switching the idea of input and output. So what this is saying is, what happens if our input is the balance? What would we get as the output? So first off, the way the ATM machines and things operate, they're not going to ask us for the balance of our account. That's just not how it works. And that's because people can have the same balances for their accounts. There might be multiple of us with a certain amount of money in our account, and with that, it'll try to give you multiple account numbers that match up with it. And that whole operation is not how a function works. So to have this input value and then to have these multiple outputs, the idea is that there would be multiple bank account numbers that could be outputs. Multiple bank account numbers. So how that's working is, no, that is not how a function works. All right, let's talk about our notation. So for notation, we have this f and then parentheses with an x inside equals y. So how we would read this is y equals f of x. So what we're getting here, f is just the name of the function. And that letter is going to change. We might have h of x or k of x. We use different letters. Maybe sometimes there'll be context to the scenario, like if we're trying to find the price of something, we'll use p of x. So that'll change. It's just the name of that particular function. And then x is our input. So x is inside the parentheses because that's what we're plugging into this function f. And the output is on the other side of the equation, which is going to be y. Now those variables can change also, x and y can change, but it'll hold this idea of input and output. So y equals f of x means that y is a function of x, or more specifically, y is the output that the function f associates with the input x. So we plug in x, that function f does something to x to change it into y. Just like our machine that we were talking about, we plug in x, that function f changes it around. With the machine we were working with, specifically it's 2x plus 3, and then we get our output y. So if I go back to that example up here, so we talked about how we have this x equals 4, and then I described it as y equals 2x plus 3, but what we could do is change the notation so that it's f of x equals 2x plus 3. So in terms of notation, what we're doing is if I want to plug in x equals 4 into this f of x equals 2x plus 3, the notation I would use is f of, and we're letting x equal 4, so I'd be looking at f of 4. And in terms of simplifying, where I have my 2x plus 3, I'm going to go 2, and where I have x, I'm just going to replace it with parentheses, and then plus 3. And then where I had those empty parentheses where x was, that's where we're plugging in 4. So when we simplify this, we get f of 4 equals 11, which is the equivalent of saying y equals 11, but seeing this notation can be really helpful because we can see the name of the function we're using, we can see our value x, and then we just need to know that whatever's over here is associated with y. All right, so let's go to this next page here with some more examples in using this function notation. So we have this function n equals f of y. So here we're changing the lettering a little bit, but even though y is inside the parentheses, and we've been talking about y as the output, because it's inside the parentheses, that's making it the input. So this capital N, which is on the other side of the equation, that's our output variable. All right, so n equals f of y gives the number of police officers n in a town in year y. So this input y is representing year, and this output n is representing the number of police officers. So what does f of 2005 equal 300 tell us? So we have f of 2005 equals 300. So the structure of our function, what's inside of the parentheses is the year, and what's on the other side of the equation, that 300, is the number of police officers. And really that letter F doesn't matter. I mean, it does matter in the sense that it's matching there. If somehow that changed in this, then we would be working with a function that we didn't understand. But because we're matching this notation and using that function F, that's how we know input is year, output is the number of police officers. So what this tells me is that in 2005, there were 300 police officers in this town. All right, so there's a nice little example with context to it. Let's do some examples where we're simplifying algebraically. So we want to evaluate the following. So we have f of x equals 4x plus 5, and we want to find f of 2. So what we're being given here is we're given our input, and in this case our input is x. So we're being told what x is equal to. And what I like to do with these scenarios, so I have f of x equals 4x plus 5, I just write it down as f of, and I leave it blank inside, and that means it equals 4 times, and then blank parentheses, plus 5. This is really the structure that our function's giving us. So f of blank equals 4 times blank plus 5. And the idea is that whatever we put in the parentheses have to match up exactly. So in this case, we're inputting a value of 2, so f of 2 is equal to 4 times 2 plus 5, which is 8 plus 5, which is 13. So f of 2 is equal to 13. So what we're ending with here is x equals 2, y equals 13. If we were trying to graph this function, this would actually be giving a coordinate to 13 if we wanted to take it that far. All right, g of x equals x squared minus 2x plus 6. So g of blank equals blank squared, and parentheses are super important here because especially in this case when we're plugging in a negative, you want to make sure that negative gets squared. So blank squared minus 2 times blank plus 6. So we have x squared minus 2x plus 6. Now we're plugging in negative 3. So we're going to be taking negative 3 quantity squared, and then minus 2 times negative 3, and then plus 6. So negative 3 squared is going to be a positive 9. Negative 2 times negative 3 is a positive 6. And then plus 6. So we have a 15 plus 6, which is 21. So g of negative 3 is equal to 21. So these cases here are the idea that we're given x, and we just plug it into our function and solve, and we end up with our y value. What we're going to do here is switch it up a little bit, where now we're changing, instead of evaluating, we're solving. So in this first case, we're given h of x is equal, so we want to solve h of x equals 20 if h of x is equal to 2x minus 8. So what we're essentially given here are two expressions that are equal to each other. Both of these are equal to h of x. H of x equals 20 and h of x equals 2x minus 8. So what we're going to do is set 20 equal to 2x minus 8. And we're going to solve for x. So let's see, I'm going to add 8 to both sides. So 28 equals 2x. Divide both sides by 2. So x is equal to 14. So that's our solution. So what we would have here is that 20 is equal to 2x minus 8 when x is equal to 14. All right, let's do the same idea. So we want to solve f of x equals 5 if f of x is equal to x squared plus 4. So f of x is equal to 5, and it's also equal to x squared plus 4. So what we're doing here is solving 5 equals x squared plus 4. So we're going to subtract 4 from both sides. So that'll be 1 equals x squared. We're going to take the square root of both sides, and we want to remember that square root property, where if you take the square root of both sides, so it'll just give us x, since x squared with the square root is just x, equals, but because we took the square root of both sides, we're going to have plus or minus. So we need both of these solutions, and square root of 1 is just equal to 1. So we end up with two solutions here. X can equal positive 1, or x can equal negative 1. So I like doing these back to back so that we can see the difference between the scenarios. Basically, these first cases where we were evaluating was that we were given x and plugging in to solve y. For these cases, it's like we were given the output and we wanted to solve for the input, which can give us one solution or multiple solutions. But up above here where we evaluated plugging in a value for x, you should only be getting one solution because that's the property of functions. All right, one last example here to kind of tie it together. So we're given the function f of x equals x squared plus 2x. So this first scenario, we want to evaluate f of 4. So that's the equivalent of saying plug in x equals 4. So f of 4 is equal to, and if we're usually taking x squared plus 2x, this is the same thing as doing 4 squared plus 2 times 4 if we're evaluating f of 4. So 4 squared is 16 plus 2 times 4 is 8. So f of 4 is going to come down to a 16 plus 8, which is 24. So evaluating, we plugged in x, and we essentially got a y value out at the end, and there should only be one solution. With this next case, we want to solve f of x equals 3. So we're going to take that 3 equals, and our function is x squared plus 2x. So 3 equals x squared plus 2x. Now this is a quadratic, so what I need to do is subtract 3 from both sides so that I can have a 0 on one side of the equation. So 0 equals x squared plus 2x minus 3. And then 0 equals, and I want to use those properties of factoring. So I'm going to factor this x squared plus 2x minus 3. Let's see, we're going to have x, and it looks like a positive 3 and a negative 1 together is going to work for us. So again, I'm thinking of 3 minus 1, that's giving us that positive 2 in the middle, and then negative 1 times positive 3 is giving us that negative 3. So we'll split this up. This is the same as x minus 1 equals 0 and x plus 3 equals 0. So add 1 to both sides. X equals positive 1 is a solution. Subtract 3 from both sides. X equals negative 3. So for these cases where we're solving, you might get multiple x values, you might get one x value, you might end up with no solutions. That's a possibility too. But there's more flexibility when we're solving for x in terms of the amount of solutions, whereas this first case, every input has exactly one output.